So a couple of practical tips with voting for the Huff transform. One thing you want to do is try to not do too many irrelevant votes. So try to minimize sort of edge elements that are not robust or highly unlikely to be useful. Because remember, we don't have to find all the points along the line, just enough of the points. You want to choose a good grid discretization for your Huff accumulator array, right? How many bins you make. And there's no sort of magic answer to that. It's a little bit of an art. The problem is if things are too large, the bins are too large, then too many sort of false points vote for the same bin. And if the thing is too fine, then a little bit of noise will cause you to vote for the wrong bin. So there's this trade-off. It's sort of how coarse and fine the data structure is. There are other things you can do. You can actually say, well, I'm going to take my point and I'm going to vote for the bin. But maybe I'll also vote for bins nearby, because maybe I'm not exactly where I need to be. It's a little bit like smoothing in the accumulator array. That actually can help. Using the gradient or the edge direction reduces the degrees of freedom of your voting by one, and sometimes that's very useful. And then the last thing is, once you found, let's say, the circle or the line, you could go and draw it in the image. But if you actually wanted to find the edge points, well, you could do a couple of things. One is you could actually try to look along that circle looking for those edge points. Or you could have been more clever to begin with. You could have, when you voted in those buckets, in those bins, you could have kept track of every point that voted for that bucket. And then once you have a winning bucket, you go and you look in that bucket, and there's the list of points that voted for it. And that way you could find the points in the edge image that actually selected that object.